Hello everyone and welcome to our webinar on Docker container misconfiguration and escape. I am Nandini Bharadwaj, the operating officer at CyberWarFare Labs, and I'm excited to have you all here with us today. So let's get started. Before we start, let me tell you a bit about us. We are CyberWarFare Labs, a UK-based company focused on cybersecurity education. Our goal is to help people tackle cybersecurity challenges with practical solutions. We have got two main divisions to our company. The first one is Cyber Range Labs. This is where you get hands-on experience with cybersecurity. We have built a virtual platform where you can try out a real-life scenarios and sharpen your skills with practical exercise. And the second one is Upscaling Platform. Here, we offer a bunch of courses for people at all skills level. Whether you are just starting out or you are a seasoned pro, we have got something for you. Our courses cover domains like ethical hacking, red teaming, blue teaming, purple teaming, and cloud security. Our training services are available to educational institute, government agencies, and corporate organizations. Both online and offline training options are available. Want to know more? Drop us a line at support@cyberwarfare.live. So let's move to next slide. So our speaker of today's webinar is Mr. Yash Bharadwaj. He is a co-founder and chief technical director at CW Labs Private Limited. With over 6.5 years of experience as a technologist, Yash is highly focused on discovering new offensive engagement techniques and procedures. His expertise includes designing, building, and teaching red and blue team lab simulations. Yash has delivered hands-on trainings at prestigious events such as NullCon, ZeefCon, NordSec, besides, and CISO platforms, and many more. You can connect with him over Twitter with his account as Flop Yash. Dear participants, as promised, we are excited to share that you will receive your attendance certificate within the next 48 hours along with a video recording of the webinar. So, thank you for being the part of our webinar. We look forward to your continued participation. And from here, without further ado, I would like Yash to take over and let's get started.
Okay. Yeah. Thanks, Nandini. Thanks all of you for joining this fantastic webinar where we will be exploring about Docker misconfigurations and some of the escape, etc. So let me quickly go through the agenda that we will be covering in this webinar. So first of all, we will be starting with Docker 101, like the basics of the Docker, what it is, and basically how things are, right? So all about the Docker. Then we will move forward and we'll cover the Docker commands. So some of the commands will be, you will be familiar with the things, but if you are not, you will gain interesting insights onto this. Then we will move forward and learn about the misconfigurations as well as the exploitation related to application based, then configuration based, and the image based. So we will learn about these things. At the end, we will be covering a very interesting case study that how the threat groups have infected public Docker image and how they have moved forward in the organization or compromised an entire organization. Then we will be covering some of the defense tactics, and then we have the conclusion. So yeah, I think we'll move forward. So first of all, thank you all for joining this, and we are doing this sort of webinar every week. So feel free to follow us and understand like what are the things that we're doing, and it's completely free. So we are just trying to share our knowledge, what we are building and what we have in our own platform, that is Cyber Warfare Labs. So let's quickly start about this, that is the Docker 101. So Docker as a project was released in 2013 as an open source one. So the link is already there. You can explore it. So it's just a software which provides us a platform where we can run multiple things like applications, etc. Now, why the Docker was introduced in the first place is that previously the legacy architecture was of VM, virtual machines, etc., that were used in the organization. To introduce the microservices architecture, that means like an application has multiple components, right? And to run these components in a combined way, and it delivers or it serves to the customer or to the client, microservices architecture was introduced. So Docker is one of a kind of a software or a platform which is used to run or orchestrate these sort of things. So Docker is an isolated and reusable, it provides an isolated and reusable containers based on customizable images. We will see these terms in the next slides. Docker is supported by multiple operating systems, including Linux, Mac OS, and Windows. It is guided by Open Container Initiative or OCI, and it is available with both CLI as well as GUI. So this is how the things looks like, and the logo and etc. So this is the life cycle through which the Docker can be, or we can manage the application via the Docker. And this is how it looks like we can, let's say, build some sort of Docker images, we can deploy it, we can run it, we update it or maintain it, manage it, and then these are the steps that keeps on going and going. So let's understand the basic components of the Docker. So first of all are the images. So images can be thought of as sort of a basic building block or a template. It consists of file system and instructions. So you might be familiar about images as in ISO images, right? Where we can deploy it in a, let's say, a VM, or we can boot it up in a physical machine, etc. So in the Docker world there are the templates, or we can run multiple applications inside an image. We can distribute it thoroughly to the customers, and it consists of file system and instructions. By file system, it means that it has the separate sort of, or the same directories that you can see in the Linux world, right? Slash bin slash user, etc., and some sort of instructions are there. So these can be thought of as a template, and I will let you know how these images looks like in a minute. Then from these images we can create a container. So container is a runnable instance of an image. That means we can create our own custom image, and it's redistributable, right? That means we can distribute it to anyone as per the licenses, and we can spawn the containers out of this. So what are container? These are the runnable or a very small instance of an image. So let's say if the image is regarding running an Apache server in a container, so that is what the container will do. It will just run it in a very small process block, and then your service, that is Apache, will be up and running. So this is what a container is. It's a very small running instance of an image. Then we have the volume. Volume can be thought of persistent storage, that is whatever things are present inside the container is handled or is stored in the volume. So volume is kind of a storage, and it can be attached or detached to a container. So this is what the volume is. And the fourth and the important one is the network. When you have created a container, how it talks with the client, how it talks with another applications, so these things contains the information about that. So there are four important Docker objects, right? So first one being the image you can customize, you can create your own image, right? Second is the container. So out of this image we can run a container, we can spawn a container, that we will see in a minute how things looks like. And then we have the volume is the storage where all the details or the data about the whatever packages installed or anything are installed is stored in the volume. And then we have the network requires connectivity with the client or with the application to perform such operations, right? So these are the basic building blocks of the Docker objects, right? Now, moving forward, how Docker works and what are the things. So Docker, as already mentioned, is sort of a software which handles all the communication and orchestration of the images. So we can understand these things in three formats. First of all, we have the client, right? Client means who will be, sharing the or making a request to the Docker host, right? So Docker host is can be thought of a machine or a physical, it can be a physical machine or it can be a virtual machine which runs this Docker software, right? So that is the one. And third is a registry. So registry is a place, it can be local, it can be remote, right? And this stores the images that we have just talked about in couple of slides before. So images can be of Nginx, it can be of Ubuntu, Python, Node.js, extraction. There can be extensions and plugins as well. Now, from the client side or whoever is trying to spawn a container, they run these or they issue these commands like docker run, docker build, or docker pull, right? So once you install this Docker software or this particular application, you can run this sort of commands like docker run or build, or you can pull it. Now when you run the docker run or these sort of commands, it directly goes to the Docker host, that is the Docker daemon, and here the server is running, we can say Docker service is running. So it operates in the client server model. This is the server and this is the client. Now the request is sent to the Docker host and it understands the request, and based on that it moves forward or perform further instructions. So let's say if the image that the client would like to run is present locally means in the Docker host itself. Let's say the client is trying to run images like this, let's say Python or let's say Redis or this one, right? So if it is present here, then it can spawn a container like this, you can see, right? So how the internals and all the details looks like, we'll see in the demonstration soon, but this is how the things are. We can spawn a container exactly like this, right? But in case when the image is not present locally in the Docker host, then the Docker is intelligent enough that it makes an outbound request to the registry. The registry can be adjust or you know uh, configured by the administrator itself. It can be a remote registry or inside the organization premise, etc. So the Docker daemon then make a request to the registry. It can be public registry, and then it downloads it. Then it spawns the container, right? So this is how the things are. We have three important things. One is the client who will be making the request. Second is the Docker host or the Docker daemon, the software which will be understanding the request. And based on the request that the client has done, it will be spawning a container. If it exists locally, then it will not make a request. But let's say if the container or the image is not present locally, then it makes an outbound request to the registry, and then it downloads it and then runs the container for you, right? So this is how the exact flow is that happens on a very minimal basis, right? So this is very interesting stuff to understand, very basic one. Now, moving forward, as already mentioned, that Docker operates in a client or server architecture. Docker client can be accessed via both CLI or GUI based on what OS we are installing, right? So basically, in the Windows, the things are the GUI or the Docker desktop is installed. For the CLI, we can use in the Mac OS or let's say in the Linux box as well. So the client issues commands to the Docker daemon or the Docker D with the help of REST API calls. So in the last image, if we revisit, so the client making a request to the Docker daemon is happening via the REST APIs, right? And the Docker daemon executes the request associated with the API calls. So if the client is trusted enough, the Docker daemon will execute the commands that is sent by the Docker client. Now, images are stored in the Docker registries, as I have already told you. So these are the things related to the Docker mechanisms. Now, how an exact container is spawned, if we go into the details. So this is how the things looks like. So we have the Docker client, Then it makes a request via REST APIs to the Docker daemon. This is the server running locally on the same machine on the host itself. Then it performs such sort of CRUD API, that is these operations, that is create, read, update, and delete, right? So these are the operations that are performed on this particular service, that is container D. The container D basically extracts the OCI bundle, and then we have the run C plus shim present here, right? And this particular process run C is responsible for running a container, right? So as soon as you execute some commands like docker run or docker build, etc., so these are the things that comes up. So when you are creating a container, first of all, Docker client issues a request via REST API to the Docker daemon. All these are happening locally. We are not talking any remote server client model. It all happens in a local system, right? Then we have a CRUD API, that performs the operation like create, read, update, or delete, right? On the container D service, this container D extracts the OCI bundle, right? Open container initiative OCI bundle, and then runs the, with the help of this process, run C plus shim, we run or spawn the container, right? So these are how the things are, if we go into the detail, right? Now these are some of the Docker commands like docker pull, right? So we can extract the things directly from the Docker hub, right? Then docker run, docker ps, etc., docker stop. So let me show you a very interesting example on how things looks like. So let me exercise into one of the server, and I will show you how the things are. Okay, so currently I'm logged into one of the machine, that is the CWL, and here I have already installed the Docker. So if you run, let's say, commands like docker image ls, this will show you the images that are present locally on my machine. So these are the name, that is the repository name is, let's say, container escape or the initial access or alpine. What is a tag that is associated with this repository, image ID, when it was created, and what's the size of it, right? So these are the things that is present here. Now if you would like to, let's say, check the containers that are running now, so you can run command like docker container ls. As of now it returns null, that means no container is running right now, right? So these are the things how we can check what all images are present here, or what are the containers that are running, right? Now if you would like to run a new container, you can do that via this command, docker run dash dash rm dash it for interactive, right? And let's say if you would like to run this alpine one, it will run that. And yeah, I think that is fine. So as of now you can see that I am currently inside a container. So this is a very simple command to understand that you are running a container in a interactive way, right? So docker, it's running, and this is one of the image name, that is alpine. Rm refers to a switch that once the user exits from this container, it will automatically remove it. And it means the interactive one, right? So this is how the things are. The host name is this. Now if I exit from here, I will be back to the new prompt, right? That is the same prompt that I was here previously. Now if I run it again, it will provide me with a new name. You can see that the name of this container is changing automatically based on you know like some of the things, right? But this is not the same container as it was previously running here, right? So these are the very basic stuff on how you can check the docker images that is present locally, or let's say if any container is running on the machine, so you can use this command, docker container ls. And if you would like to run a specific image and spawn a container out of it, you can use this particular command. So that is how the things are. Now moving forward, let's cover the interesting stuff that everyone is waiting for, that is the docker misconfiguration. So there are few misconfigurations that arises because of these few things. So first of the things are that permissions that are granted to the container. So when we are running any commands like how you saw previously like this, right? So if we add any capabilities or any permissions while running this particular container, so what will happen in that case is that the container will have excessive permission what it has been granted to, right? But that means like, if we are adding some root level access, or let's say some capabilities or some sort of permissions while running, so it's highly possible that that a pen tester, or let's say an attacker landing into the container directly, can escape to the host, docker host, right? So that is possible. That is one first case. Now, moving on to the second case, that is running Docker images from the untrusted source. So we have a very interesting case study on this second topic that I will be covering at the end, right? So if the developers have the tendency that they can, without even checking the repository if it is trusted or not, if it is verified or not, if they are running the Docker images or downloading it directly from an untrusted source, so that is a very huge severity or some sort of things that needs to be taken care of. Also, host to container configuration, when we are running these things, what sort of permissions or configurations are attached to that, so that is one of the case. Then we have the container having access to a host network. That means if the container that we have spawned has access to the host network, that means it can sniff the host network details, etc. So that is one of the case as well. Then user who is spawning the container added to a docker group, right? So as of now, let's say if the user here cwl is added to a docker group, then there can be some sort of misconfiguration that might arise, right? So based on the time limit, obviously I will not be covering all of the same things, but I will try to cover three major demos that I have prepared for you. So yeah, I will move forward quickly. So the first demonstration is regarding the initial access to a container. So let me quickly, fire this terminal and yeah. So in this particular demonstration, what we will be doing is we will be simulating one attack where this is one of the command, right? So what we will be doing in this particular setup is we as a pen tester, or let's say an attacker, will land into one of the web application, and even without exploiting anything, we will try to see if we are in a docker environment or not, right? And if we are in the docker environment, then what we can do. So what this command will do, it will run one image that is of the name one dash sorry, this one initial access. This is the tag that is attached to it, and we are exposing port 10,000 on this, right? So this is a vulnerable web application that we have custom designed for this particular webinar. So let me run this, and it gives some sort of output, right? So this is the image id or something. So now let me quickly go to the location of the docker host. So let me run this, and here you can see that as soon as we run here, that on the 10,000 port, the webmin server is running, right? So let's say you as an pen tester or red teamer have identified the credentials, or let's say you try with the default credential, let's say root and root, and as soon as you log in, you are in the dashboard. You can see the details, or you can see the internals, how things are, right? So these are the stuff you can try to explore what the things are. Other than that, what all information you can gather from this particular application, etc. Now there is a very interesting functionality here on this webmin, that is we are able to perform command execution on this. So there is a small tiny command shell here. If you open this, then you can see that we are currently running as a some sort of a unique name. We do not know if we are actually in a container or not, right? So to confirm if we are actually in a container, what we can do is we can look for a file named docker env, right? So if this particular file is present, that confirms that we are currently inside a docker container, right? That means we are inside a container. Now as a pen tester, what the thought or what the next step would be to check, or like whatever capabilities or permissions are attached to this particular container, and how we can escape from this container environment to the host environment, right? That is the actual VM or the machine where this container is running. So these are some of the things that that is very important while understanding the while performing penetration testing or assessments, which environment we are in currently. So this is obviously one way. However, there are other ways as well through which we can know if we are landed in the Docker environment, right? So this is one of the way, like if we are added, or if we can see the Docker env file, that means, or that confirms that this is obviously a container that is running in one of the VM, right? So this is how the things are. So as you can see how it's possible to run some such sort of application in a containerized environment, right, in a Docker image, right, and only is with a single command. So that is one of the stuff in here, right? So this is one of the demonstration. Now moving forward, let's move to the second demonstration, that is mounted volume misconfiguration. So here what we will be doing is that while spawning the container, we will be attaching some access permission to it, right? And that will obviously map us or provide us access to the host environment, right? So that is what we will be doing. So the second demonstration, that is mounted volume misconfiguration. Let's start it. So let's first of all check whatever containers are running, right? So we can see that these are some of the recent container that I just started from this command is running here. I can stop it like this, docker container stop, and then the container ID. So if I pass the ID, it will be stopped, right? And if I want to, let's say, remove it, I can remove it using this command rm. Sorry, yeah, so it's, if it is stops, that means it's already not running here. So these are the things that you can see. Now let's quickly jump on to the second demonstration, that is the mounted volume misconfiguration. Okay, so let me run this command. What this will do, we are trying to run one container, that is container escape, with this tag latest. All these images are present locally, it's not present outside anywhere. We have custom developed for this webinar. Now what we are doing here is that we are mapping the slash home folder of the host that is on this particular Docker host, right, on this machine, the VM that I'm currently in, with this particular file, that is slash root. So instead of slash root, how about if I change the name to, let's say, um, CyberWarFare, right? So something like this, right? So that should be the case. So what this will do, that this particular command will run this, or provide me a bin bash shell inside this particular image or this container Docker escape, and it will also map the directory of the Docker host. Host means the VM that I'm currently running, right? With this particular folder, that is CyberWarFare, right? So let me run this. Okay, so as you can see, I'm currently inside a container. If I do ls, here you can see that there is one directory called CyberWarFare, right? So let me go inside this directory, right? And if I do ls, then I have access to the two user directory, that is cwl. This is one user, and another user is the demo user, right? So since I have access to the host location, or to the host directory, let me do some trickery here. I will go to the location, that is demo user. Then I will modify the bash rc file by going to the bottom, right? And here what I will be doing is just placing one reverse shell command, that is this one. And what this will do, it will give me a reverse shell back to my attacker IP, right, on this particular port 1234, right? So this is what it will be doing. I will save this, right? And if you check the bash rc file, in the bottom, this particular command that I have just added as an backdoor is present here. Now remember that I am currently inside a Docker container, but I am able to access the host directories, right? So I am currently inside this folder, which was used to map, if you recall here, right? So if you go to the top, when I run this particular command, what happened was that the slash home directory of the host, Docker host, that is this one, is mapped to this location, that is slash cyber warfare. That means I have successfully escaped as an attacker, or let's say as a pen tester, from the Docker, from the container to the Docker host, right? That means I am currently inside the, files or the directory of the Docker host, not in the container, right? So make sure that whatever we are doing, we are present inside the Docker host. And this is one of the user, that is demo user. Okay, now let me open another terminal here, and I will run the netcat, right? So it's now running in this particular port, that is 1234. Okay, now let me open another PowerShell here. And now what I will do in this particular setup is I will try to SSH into this particular machine as demo user. Now, as soon as I SSH into this machine, the bash rc file will be invoked, right? And as soon as this file is invoked, it will execute whatever is written inside it. So there, some of the things are already present, but if it executes this particular command, that means the our reverse shell, we should have a shell back to our attacker machine, right? So let me just SSH into this machine onto the Docker host as the user demo user, right? So you can see SSH demo user, and this is the IP address here, right? So I will just run it, and I will write CWL. Now, as soon as I run this, you can see that I have a shell back on my attacker machine here. Okay, okay, I think something happened here. I'm not sure what, but yeah, okay. So I have got the connection here, right? I think it's some sort of things hang, but this is how the things are, obviously, right? So that means like the purpose of this demonstration is that with the volume addition, or that is the mounted volume misconfiguration, I have successfully landed on the machine, right? And all the things started from this particular command when I started the container with this sort of mounted volume configuration, right? That is the whole Docker host home directory will be mapped to this particular directory. This is some random directory, right? It can be anything. So as of now, I have mentioned cyber warfare. Now, as an attacker or as an pen tester, I can go to this directory, and it has already mapped to the slash home of the Docker host. Now, whatever I do inside it, it will be, completely reflected in the host as well, right? So let me exit from this, right? And as of now, you can see I am on the Docker host, that is the CWL. Now if I, let's say, go to the slash home slash demo user, right? So if I go to, let's say, slash home and then demo user, and then do the bash rc, cat the bash rc, you can see that this tiny little command is reflected here. That means from the Docker container, I escaped, or I modified something onto the bash rc file, and I compromised that, right? So this is how the things are in this particular case section. Okay, so this is how the things are, right? The mounted volume misconfiguration, and it is highly recommended to not run these Docker containers via the root users, right? Now, coming back to the very interesting topic, that is the case study, right? So back to basics, right? First, we will understand some of the things. So I already told you that images are the base of any container, right? Images can be hosted on publicly or private available repositories. For example, Docker Hub. right? And anyone can upload their own images, right? So it's very easy to distribute, it's very easy to compile, build, and then upload it somewhere. So anyone can upload their own images, it's possible. And public images can be downloaded, pulled by anyone, right? So in past, threat actors have uploaded malicious images of legit software on the Docker Hub, right? So what's the tendency of the threat actors are that they try to create or build some malicious Docker images, and then they push it in the trusted Docker Hub repositories, right? Either they create with a similar looking name. We will see in the example that I will be, I will do the demo on this, and then they try to fish the developers of an organization that they're targeting, and based on that, these things work. So this is the case study that I will be simulating right now, right? So we have the attacker here who has control of the C2 server, right? Now via some malicious code, they add in a Docker file. So Docker file is a very simple, kind of a file where we can add all the details that are required to build an image, right? So this Docker file can be backdoored. You can say a legit Docker file can be downloaded from GitHub or from any trusted repository. Attacker generally adds some backdoor in here, right? And then they compile it to a Docker image like this. Then this Docker image is uploaded to the Docker Hub. So this is the official location. It's just like GitHub but for the Docker, right? So Docker Hub contains all the information related to the images, etc., right? And the backdoor Docker image is now uploaded here. Now the let's say the attacker successfully tried to fish it, and the attacker is successful in that way, let's say, right? Now what will happen is that the user will be provided with a malicious Docker image, right? It will be downloaded, and let's say with some sort of instructions, or the user is trying to do something on the organization laptop or their own machines, then the container will be run by the user. As soon as the container is run by the user, then what will happen is that the malicious code will be executed directly, right? And this user will have a shellback to the C2 server. So this is just an example that I will be demoing right away, right? So very easy, right? Attacker creates a malicious code, adds it in a Docker file. Docker file will be compiled to the Docker image, which will later be uploaded to the Docker Hub, right? Then via some sort of phishing, or let's say by gaining some trust, attacker try to add or lure, or let's say fish the end user or the organization employee, and trick that user to download the official, or let's say, sorry, not the official but the malicious Docker image. As soon as the user downloads this Docker image, that machine will be compromised and the malicious code will be run, right? So that is how the flow looks like. So let me show a very quick demonstration on this end, how things looks like and what are the stuff here. So yeah. So currently I am on the Docker host, right? So this is one sort of a thing. Let me go in here and let me show you how a Docker file looks like. So this is a very simple two-liner Docker file, as you can see from Alpine latest. So Alpine is one of a very small container, sorry, a Linux, image, right? So we are pulling from here, that is Alpine latest, and CMD means take the command to execute while deploying the container. So this is one sort of a command that will be executed here, and the attacker, let's say, has added this malicious code into this Docker file. So this is a very simple Docker file. You can see in the organization that there are various multiple build stages are present, or there are multiple stages for building, or let's say it's a very big file, right? Docker file. So here it's very simple. This is the legit command that is from Alpine latest, that is the it will pull from this repository this particular image, and it will execute this command, that is CMD, this particular one, right? And what this will do, it will make a connection using ncat to this particular IP address, which is the C2 server or the attacker IP address on this TCP port, and it will execute this slash bin slash sh, right? So this is how the things are. Now, what I will do, let's say as an attacker, I have created this Docker file, right? I will be uploading it into the remote Docker registry. So how I will be doing it, using this particular command, that is docker build. So let me run this command, docker build slash t and pod check. So I want to name it, let's say pod check, so that it looks some sort of legit, right? And that means like the docker file will be taken directly from with this command. So I will run this, and here you can see that the build is finished, right? It's present here. Now if you do command like docker image ls, so here you can see that the pod check image is now built and present here, right? It's only of 7.38 MB, right? That is the thing. Now I will now run the second command, that is the tagging. So I will tag this with this command. Now what this will do, uh, Google Co, so this is one of the repository that I have created just to gain some upper hand on identifying just by the name, right? So people looking into this particular repository check that this is the official one, right? Or let's say it belongs to the Google company, etc. But it is not, right? It is owned by, like we have just randomly created on the fly, and people, most of the developers get mistaken or fooled by checking the name, right? So if the name looks something like this, if you are creating a Docker Hub repository, if the name if there is availability of the name that you can use it, and it looks similar to the target organization, that we can use that as well, right? So now what I'm doing, I'm tagging it this spot check, the image that I've created here, and it will be uploaded to this particular location, right? So I've just tagged it. Now if you do the docker image ls, it's now present here. So I've, the tag is done, it's on the latest end, and the same stuff is here. Now I will be pushing this to the Docker Hub pod check, and this one is sorry, this one. Okay, so as soon as I run this, what this command will do, it will push this particular image to the repository, that is this repository, Google Co slash pod check, and you can see and identify the things in here. So you can see they are already accessed. The push refers to the repository, this one, and it's now pushed successfully. That means it has now been uploaded to the docker.io, the official Docker Hub repository, right? In this, with this particular naming stuff, right? Now, since as of now this is private, right? It's not public. Okay, I have already logged in here and I have pushed it, so that's how it works. But generally, you will, as an attacker, you will be making it public so that the users can download it, right? So these are the things. Or if you want to establish any trust, or let's say you are talking to one of the developers and would like their help on your project, you can send them, let's say, the personal access token or these credentials, so that the users can log in there. So that also works. So this is how the things are. It's as easy as this. Whatever what we have done is, first of all, this is how our Docker file looks like. It will pull this Alpine um, Linux, right, from the repository, then it will run this command. Okay, so I have built this particular file and then checked it in the image section. It is present here with the name pod check. Then I have tagged it, right, and tagged it with this particular repository, so a new image name will be visible here. Then I simply post this particular image name to the repository. So whoever like I send this particular repository, if she successfully run this stuff locally in their machine, their things will be compromised. Obviously this is a local setup, so it will not work publicly, but just for the demonstration I have told you these things, right? Now let's do the interesting stuff, that is running the things. Okay, so first of all I will start my netcat listener here, and my, yeah, netcat listener here, and I will start the VM here. Sorry, not the VM, but the Docker image. So what this particular command will do, let's say that I'm now playing the role of the victim, right? So before this, what you saw was the kind of a part of of the attacker, how the attacker created the malicious Docker file, and how the attacker has built it and posted to this repository. Now the important thing to note here is that the name of the repository, whatever name you will be choosing, it depends heavily depends on the next operation, right? Or if the user will be convinced to download this or not. So if you look at this particular repository name, it looks some sort of official, right? It's not a look like it's some sort of malicious thing is happening. Even we got the name as Google Co, etc. You can try to choose any other name as per the target organization. Now what this will do, this particular command will map the slash of this repository of this docker host with the slash twl directory, right? So let me just run this, and during running it will run that command that we have used to backdoor, and we will have a shell back on this on the c2 server, let's say. So let me run this. Yeah. So here you can see that there is a connection made to the attacker to the C2 server, and I can successfully run the command and do the things, whatever the stuff is, right? So everything will be visible in here, and you can see that the directory that I was mapped with, that is the slash cwl, is also present here in the slash cwl section, right? Now based on the privileges or the capabilities that are attached to this particular container while running this command, it's a very simple command, right? There can be very complex one, like while deploying or while using it in the organization level. So these are how the things works, right? And as you can see that I have successfully got the shell. Now I, as a red teamer, would try to see what all things I can do from this particular way, or from where I am currently, how can move to the docker host, and then expand my access to further achieve my objectives that what I have been allotted with, right? So these are how the things looks like, okay, in here. And this is a very interesting case study that we have just showcased as per this particular webinar series. And if you would like to try out, do not replicate these things and share it with anyone else, like the malicious docker images, etc., right? Do it in your own vicinity, right? Like with your own machines, or in your own VMs. Okay, so I think this is all about the demonstration that we had. Now I will talk few points related to the Docker defense. So these are the few points, that is, do not allow root user to run any container, right? So that should be the first pointer. Also, this is very important, that is vet images before pulling from repositories. That means the images that we are pulling from has to have a proper sort of kind of a checks or sanitization checks before even we pull from any repository, that if it is trusted or not, etc., right? So these are the things. Drop all capabilities and assign only the needed on the needed basis, that is, do not, it's not required, right? So some of the developers or the DevOps team, what they do is they try to run these same set of commands with by just copy pasting in some sort of documentation that they may find, or let's say um, you know even some of the developers right now are directly copy pasting from applications like chat gpt, or any other, etc. So what happens is that they don't understand what are the implications that are attached to it, right? So if you, it's fine, you can run a container, but if you are adding excessive permission to it, then there will be consequences, right? So these are the things. Now include multi-stage build while running a docker file. So if you just saw in our last example how like it was a very simple docker file, but in case if it's a very big one, so always include in sort of stages, that is multiple stages when we are compiling any docker image, right? So that is one of the things. and remove unnecessary permissions if not required, obviously. So if it is not required, do not add the capabilities or do not add any specific mounted volume configuration, etc. So yeah, I think that's all for this particular webinar, right? I hope you guys enjoyed it. And we plan to do this sort of series weekly, or once in a couple of weeks. So we would like to expand, us, like what we are teaching, what we are doing. So everything is for free. You will find the materials as well as the details in our website, right? And you will receive the mail regarding to this. So all you have to do is just follow us on social media platforms like LinkedIn or any other, if you are active or following us. If you are not, please do that. And the best thing is that you learn these things in very short span, maybe 45 minutes or in an hour, very new interesting concepts in a practical demo way. And next time, if you would like to call your friends or anyone who are interested in such sort of topics, maybe on the pen testing side, on the red teaming side, or blue teaming, or the, let's say, purple teaming and cloud side, feel free to um, you know like redirect to us, our platform, and then explore the things, right? So yeah, thanks all for watching this particular webinar. I hope you guys enjoyed a lot. And if you have any questions or anything, feel free to message us, sorry, email us at this particular email, that is at info. If you have any specific requirement, feel free to let us know. And we have a very interesting webinar series that we will be doing next week, that is on the Azure cloud attack site, right? So if you would like to explore that, feel free to register, right? And you guys will be receiving the participation certificate within, I think, couple of days. I think that's what Nandini mentioned. So yeah, I think that will be all. So there are a few questions here. Jay is asking, when can we expect the Docker or Kubernetes red teaming courses? So Jay, we are, thanks for joining this first of all. So yeah, we are still in the process of, working on these things. So there's a lot of things that we have expanded to, if you look at our offerings. So I think it will be soon, right? We will be releasing these stuff soon, and hopefully within couple of months you will see these interesting topics related to Kubernetes, pen testing, or the Docker, these all these topics in our platform. So yeah, I think that's the stuff. Other questions. So one is asking, will you be uploading this demonstration as well? Yeah, so obviously all the things that is present here, that is the demo that we did, everything will be presented or uploaded in our website. You can just watch, and you don't have to wait, like like when it will be uploaded. We will send an email as soon as we upload everything, and it will be provided there directly, right? So these are the things. And no, like the demos that we have prepared just for the demonstration only, we will not be uploading or sharing these things directly. So yeah. um yeah, so you guys will be receiving the certificate within couple of days. At least you can expect at least 48 hours delay. That's the fast we can work on. Yeah, so that's all. And yeah, so if you guys have any specific concerns, or you would like us to deliver on specific topics, so please let us know. Feel free to drop an email that you would like to have a webinar on such topic or this topic. We'll see if we can arrange these things. Definitely we'll like to do that as well. Yep. So I think that's all for now. Some of the questions are very similar to what I had already told you, the same set of information. And if you like these sort of things, please do give us a shout out at social media platforms, right? So this boosts our confidence. And once you receive the certificate, please update these things in the social media. I think that works. Thanks a lot, Jay, for being with us for a long time, and thanks all for your constant support and joining this awesome webinar. So yeah, I think it's time, guys. Thanks all for joining this, and have a very good and very productive weekend. Thanks a lot. Thank you all.